Hello everyone, welcome back to the Precision Agricultural webinar series. Today is our second session, Dji Smart Farm Platform Preview. As the subject suggests, I'd like to do a brief introduction of our to-be-launched new platform, Dji Smart Farm. You may have heard about this product here and there, although it's still a little bit far away from the official global launch. So in order to help better prepare for what's coming up and more importantly to gather feedbacks from you of how this product sounds to you, what features and functions you are looking for, and why they might be helpful for you. These opinions would be of great value for DJI to plan out the development roadmap before the launch. Before we get started, in case we haven't spoken before, my name is Wayne Zhong from DJI Agricultural R&D Department. I joined DJI Agricultural in 2019 and has been a product engineer, mainly focusing on precision agricultural product line. After joining the team, we started investing into this new product, DJI Smart Farm, and I'm very happy to give you a preview of this new product today. Here is the catalog of today. I will introduce the DJI Smart Farm's history, major features of this product, benefits, and also the availability of this product. So why did we decide to make DJI Smart Farm? There are a couple of reasons. While more and more users start exploring the full agricultural solutions, from imaging to spraying and spreading, they now have to navigate through multiple software for each step. Right now, we are using Terra for imaging processing, a grass app for mission planning and execution, AGMS for operation management, and sometimes third-party software as well. This jeopardizes the experiences and sometimes efficiency of getting things done. Also, large amount of our users operates in teams. They could be services providers with fleets of drones and also a network of pilots. So that the current way of managing all reconstruction tasks on one desktop software, Terra, and with the high-resolution imagery data only available to one person is not going to work. An organizational way of managing drones, jobs, and data, and a way to share the data internally and externally is necessary to maximize efficiency. At the same time, this kind of data sharing is also important for big growers who works with agronomists and pilots to manage multiple farms and fields. Moreover, these services providers and big farms are looking to use strong data, such as high-resolution imageries and multispectral imageries, for more intelligent and accurate analysis for precision agriculture, under the purposes of boosting efficiency and yield, while at the same time cutting down the costs. Functions on current Terra platform is far from enough. Computation and data storage is also a problem. The demand of lighter and more accessible tool with more calculation power and large data storage, rather than relying on expensive computers at high configurations, leads to the idea of cloud solution. On top of that, cloud solution makes it possible to connect with necessary up and downstream software through open API in order to use strong data for more purposes. All in all, an integrated end-to-end, cloud-based, team-oriented, and open system solution comes to our attention. This is how DJI Smart Farm was born. DJI Smart Farm is a map-based SaaS software as a service platform that delivers agricultural drone solutions for growers and services providers to help process imagery data and manage drone operations for precision agricultural applications. From the very beginning, we have focused on tailoring the solutions for two groups of target users: services providers and growers. For services providers, including spraying, imaging, and precision agricultural services, the goal is to help them to better connect with their clients with better job documentation tool, imaging and analytical tool, and smoother data sharing and reporting process. For growers, on top of precision agricultural tools, we also care for the need of by-field management, including product application checking and field health monitoring. Here are the major features of DJI Smart Farm: cloud auto processing, farm and field management, mission planning, precision agricultural, and job documentation. First of all, cloud auto processing. Cloud auto processing reconstructs automosaic imagery from drone photos using cloud computation. It is very much a cloud version of Terra in short. Since it's cloud-based, it makes large area processing possible with no GPU and CPU limitations. Although also multiple tasks can be processed at the same time or through auto-queuing. After processed, the results are merged into one high-resolution automosaic map, which can be used on another platform as base map. For example, it can be synchronized to a grass app and appears as another source of base map, which is much clearer than the satellite imagery. With that, pilots can draw field boundaries and obstacles with good references. Comparing with the current Terra plus a grass solution, the advantage is that pilots can access the map anytime, anywhere, rather than carrying their computers around. Or this base map can be shared with someone else, both one in the organization or outside, or even displayed as a map services on a third-party platform. Second feature, farm and field management. Farm and field management on DJI Smart Farm is tree structure based. Users can manage the field by farms and subsidiaries, and also look up job records, product application history, elevation and vegetation index statistics for precision agricultural analysis by fields. The farm and field structure is the foundation of data management on DJI Smart Farm. Another feature that is also like a cloud version of Terra is the mission planning. Flat view mode, ultra mode, and multispectral variable rate application mission are all supported. Not only can the planned missions be synchronized to a grass app for operation, it can also be shared across the team, meaning those who are added as members to the account or someone outside the team who may not be using DJI Smart Farm. Therefore, you don't need to use a SD card to copy it and paste files to someone anymore. With the base map sharing function mentioned above, and also this mission sharing function, a team with pilots designated separately for imaging and for spraying can collaborate in an easier way. The imaging services providers can better share the imagery or mission planning results with their clients who needs them for the spraying jobs or other purposes too. Precision agricultural. The precision agricultural module provides tools for further analysis based on drone imageries. Elevation analysis monitors the slope of a field and calculates the cut and fill to flatten a field. Vegetation indices tool calculates NDVI and other popular vegetation indices based on multispectral imagery reconstruction results. Emergence count tool. This tool calculates amount of emergent seedlings with high-resolution drone imagery and AI recognition. Last but not least, the variable rate application prescription map. This tool has two modes, the leveling and the zonation. The leveling tool redistributes the application rate throughout the field within a defined range, either to boost the rate for area with lower vegetation index value, or on the opposite, to decrease the rate. And the zonation tool divides the field into zones based on NDVI values and allows users to specify application rate for each zone. And another function is the job documentation. Job documentation tool is designed for both the pilot and the field owner to check applications happened on the field. First, a team manager is able to check the location and the motion of the drone in the team in real time. Moreover, he or she and the client is able to check operation compliance. What that means is they are able to check if the application rate and the flight parameters, including flight height and speed, are under compliance. Any incompliant operations will trigger immediate notifications and will also leave records in the system. Furthermore, products applied are documented by field, so that pilots and growers can better check the application history for agronomic analysis or regulation requirements. In summary, DJI Smart Farm platform provides the following benefits: all-in-one platform for multiple tasks. What that means is you now can use DJI Smart Farm for reconstruction, mission planning, variable rate application generation, job documentation, and also precision agricultural analysis, such as elevation analysis and emergent count and so on. Second, no more expensive computers, because all the computation and data storage happens on the cloud instead of relying on a local desktop computer. Access anytime and anywhere. Again, it's cloud-based, meaning that all the data that you upload and generate on the cloud can be accessed anywhere as long as you have a devices that connects to the internet, just such as our remote controller, which has a Grass app installed. It could download the high-resolution imageries that you generated on the cloud platform for field boundary generation purposes, or you could access the data on the cloud using your mobile phone as well. And fourth, stay connected with teammates and clients. You'll be able to add your teammates into the same organizational account of DJI Smart Farm so that you could share and collaborate using the data in the account. In the meantime, you could share the analytical tools that you generate with your clients who needs it for field scouting or for mission plan or for the spraying missions. And last, analytical tools for precision agriculture. That is completely a new feature of our agricultural software. So about the availability, the estimated global launch time will be 2022. But from right now, a personal beta version is already available for free trial throughout 2021. In order to use this trial version, please submit the application at www.djiag.com. We will process the application in 24 hours. Afterward, you'll be able to use your current DJI account to log into the DJI Smart Farm account. This account is the same one that you use to log into your Grass app. So make sure to use the same one so that you could sync the data in between these two platforms. The functions that are already available in this personal beta version include the cloud auto processing, which supports all three modes that are currently supported on Terra, field management, elevation analysis, variable rate application prescription, mission planning, and author-based map sharing to a grass app. And now I give you a demo of this personal beta version to walk you through the functions and also to give you a onboarding experience. So first of all, the product is not yet localized, meaning that it's still in Chinese and not translated into your local language. But one trick here is you could use the browser's own translator to translate into your local language, just like what I just did. So you log into that djiag.com, and here go ahead and select login with your DJI account. If you don't have submitted the application and have it processed yet, you'll be able, here you will be asked to submit your application. Since I have already done that, what it does here is to ask me to authorize the platform to use my DJI account to log into DJI Smart Farm account. And again, I translate into English. So this is how it looks like, the beta version. The functions are limited comparing with our organizational version, which will soon be available as well. And again, because we're using a browser's translator, you might be able to see some funky translations here. But once you log in, the very first tab it takes you to is this one. It's actually a photo library tab. What it does here is you will need to create a photo library and then upload the imageries, the photos collected by either P4 RTK or P4 multispectral, which are the two drones that we support for cloud reconstruction currently on DJI Smart Farm. So you go ahead and create a new library, for example. Give it a name and select the photo type. If it is taken by a P4M, for example, you select multispectral. If it is taken by a P4 RTK and will be used for fruit tree mode, you go ahead and select the second mode. This is just the same as Terra. So I go ahead and select multispectral. You could type in some notes and then hit submit. After submitting, you go ahead and click add photo to add the photos taken by the drone. And then if we start uploading the data, once it's finished, you could either click reconstruction or go to the cloud reconstruction tab. This is where we do the cloud reconstruction. You could click new reconstruction task here and generate a task. Similarly, you select the type, either multispectral or the others, and choose the photo library which you just generated and uploaded the photo. For resolution, we always suggest the high resolution. And once finished, you go ahead and click submit and rebuild. Then the reconstruction task will be listed here. Once it's finished, you'll be able to see the high resolution orthomosaic imagery or the vegetation indices if this P4M tasks. You can also mark the original image to see the overlap between the original imagery and the result. This is a handy tool to use if you find missing parts of the results. You would be able to check whether the original imageries are missing or it's just part of the fields were not reconstruction because of some error. You can also download the results, including the high resolution imagery, which is the RGB imagery, or the vegetation indices if it is a multispectral task, and even the DSM, the elevation layer. And then you could do agricultural application, which is just the same as the agricultural application in Terra. What it does is to plan missions for spraying or spreading. And as I mentioned, the farmland mode, the ultra mode, or say the fruit tree mode, or the multispectral mode are all supported currently on the cloud platform. Browser doesn't translate this panel into local language, but I could briefly walk you through the process so you could try to follow me. This is quite straightforward, and if you have experience using Terra, it shouldn't be difficult for you. The first step we need to do is to draw a field, the same as what we did on Terra. And then we add a calibration point. When finished, we click Save and Submit, and then we go to the second tab, which is the recognition tab, the land cover recognition tab. The AI tries to automatically classify the field into target land cover, but in some fields, for example, when the seedlings are young or paddy fields, it might get misclassified. So you would need to modify the land cover classifications manually before you go into the next step. So the first one is farmland. The areas that we want to do the spraying or spreading must be in farmland class. So if there's not, you would need to manually modify the field back into a farmland class. So instead of using brush as in Terra, we change it to the vectorize tool, which might be easier for you to do polygon modification. When finished, you hit Save and Submit as well. So this field is now changed into a farmland field. And the third step in a multispectral mode is prescription. So under here, you'll be able to fill in the parameter to generate a variable rate application map. I talk about two modes, the leveling and the zonation. This current version only supports the leveling mode, and it's the same as the mode on Terra. The way it works is it asks you to specify the field first and enter an average application rate. For example, let's say 10 kilogram, and a application rate for strong growth area, as well as a application rate for weak growth area. What strong growth area means is the area with the highest NDVI, and likewise the weak growth area means the area with low NDVI value. Basically, it asks you to enter a application rate range so that the platform will adjust the application rate within this range, and at the same time to ensure that the average application rate after calculation of this field will be maintained at the average rate that you enter. So let's say we have the average rate at 10 kilogram, and we specify a 8 kilogram for the strong growth area and a 12 kilogram for the weak growth area. So what we are asking the software to do is to generate a prescription map with the rate within 8 to 12 kilogram, and at the same time to maintain 10 as the average. Another parameter is this option. If it is checked, the same parameters will be used for all the fields here. If it is unchecked, it will only be used to calculate this field. So when finished, go ahead and hit Generate Prescription. Okay, so when finished, you'll be able to see the prescription maps here. The area with strong growth rate would have a lower application rate, and on the opposite, the area with weak growth will have a larger application rate. And in order to use this mission on a graph shown, right now we only support the download option, meaning that you need to download and then copy into a SD card. About this workflow, we'll do more introduction in the following webinar series, which will happen next week. So please join that webinar to learn more about how to do variable rate application using T30 and T10. But basically, you will need to download the task here and then paste it into a SD card and then import into T30. So that is the agricultural application. Another function that is available is the elevation analysis. What it does is it visualizes the DSM, which is the elevation layer. With that, you'll be able to see the elevation of your field and whether it's even enough to start planting. Let me give you another example here. So the unit is in meter. The red color means a higher elevation, and the blue color means a lower elevation. So you'll be able to see the evenness of the fields. You could uncheck fields to view the elevation distribution of the whole constructed area, or check fields to view only the elevation within the field. So where did these fields come from? How do we add the fields to visualize only the elevations within the field? That actually comes from the farmland management, which actually is a field management tool. You could add a field by manually drawing the boundary. And hit save, submit. And then you'll be able to have all your fields here and use them for elevation analysis or even more purposes, such as job management, application management in the following organizational version. So these are all the tools that are available right now on the beta version. Another thing I want to mention is the high resolution imageries that you constructed here on this platform, on this account, will also be available on a Grass app as long as you log into the same account that you used to log in your Dji Ars Smart Farm. And on a Grass app, you can then use these high resolution base maps for your mission planning. So that's a very handy tool. You do not need to use the Terra to generate the mission and then export again. Instead, you could access this high resolution base map not just one task, but the combination of everything you constructed here on the platform will be available on your Agras app. So this is the personal account that are available to you already. Let me also give you a preview of the organizational account. So functions that we already introduced includes the cloud reconstruction, farmland management, which is translated into plot management here, and elevation analysis. On top of that, you will notice there are much more functions in the organizational account, including organization. What it does is you could add farms and also its subsidiaries to these farms for organizational management. You have user management, under which the users of the same account organization account is managed. You can add more people into your organizational account and put them into the correspondent organization subsidiary. You could also add equipment, associate equipment, meaning the Agras drones to the account, so the jobs history of these drones can be managed here, job management. Yeah, so this is one task management. The yellow lines you see here are the boundaries of the fields. When I turn off the boundaries, you'll be able to see the green and the red plots here. What it means is in these tasks, the areas that are labeled in green are compliant operation, and the areas labeled in red are incompliant operation. Incompliant operation meaning that some parameters, either application rate or other flight parameters, are incompliant. So we have one incompliant line, and it shows you the incompliant parameter is the application rate. So this is a way to check the compliance of the operation. It's a function for the team manager or the grower. Plot management or farmland management, which we already saw in the personal beta account. But the difference is here is you could manage the fields by farms and also by the sub-farms under it. It automatically calculates the amount of fields within an organization and the total area of the fields. So here's one example, 305 plots in this sub-farm, and you'll be able to see the farms, the fields, and the area of each field. Emergence analysis is also available in organizational account. Currently, it only supports codon, but we look forward to expand this function for more and more crops. Okay, so this is a brief introduction and demo of the Dji Smart Farm. And one last request we have here is please take the time to take our survey and leave your feedback. We would love to hear whether this product would be of interest to you and which module might be more useful in your business and what other functions you are looking for. We will take into consideration of your feedbacks in our following product development roadmap.